Okay, so for these two problems out of the textbook, you've already got the answers for from Dr. Stevens for number 15, but I'll do it here on the video. Let me get so they told me here's the low, here's the high for the lower bound, the upper bound of the confidence interval. And they want us to calculate the sample mean and the margin of error. So what you got to think about, remember, these are calculated by doing the mean, the sample mean, the point estimate, if you have plus or minus the margin of error. Remember that margin of error is, let's see, well, if it's a z distribution, it's z star times the population standard deviation divided by the square root of n. Well, they aren't even asking us about that. All they want to know is this whole number. So we don't have to worry about this. We also don't have to worry about whether it's the t distribution or a z distribution, okay? We just need to find that. So how they came up with the 12.4 is they went the mean minus the margin of error, and then to get the upper bound, they did the mean plus the margin of error. So doesn't that tell me that these are two margin of errors wide? The bottom and the top, because I subtracted one, add one, so that's the two. So what we're going to do is we're going to subtract, and people have showed you how to do this in the forum, or at least did when I'm doing this. I don't know if you watch this in future semesters. So I'm going to subtract that. I'm going to find out how far apart those two values are. So 13.2 minus 12.4. That's the difference of, what is that, 0.6? No, 0.6 to 0.8, isn't it? So that's the difference to 0.8. And we know that represents two margin of errors. So if I divide that by 2, that gives me a margin of error of 0.4. So, and then how do we get the sample mean? Well, the other way to do this is to take, if we know, isn't the mean the middle of these two numbers, in between those two numbers? So, because you think about it, it's up there, right? It's the mean plus or minus the margin of error. So what the person who posted this in the forum did, okay, they did 13.2 minus the 0.4, and that would be the mean. Let's see, what is that? That's 12.8, I believe. Yeah, 12.8. Because that'd be the same as 12.4 plus 0.4. That'd be 12.8. Now, the other way to do this without having to find the margin of error is just add the two numbers together. So it's 12.4 plus 13.2. It's symmetric, so we know the mean will be in the middle, right? Divide that by 2. So what is that? That's 25.6. 25.6 divided by 2. Well, I believe that's 12.8. So that's how you can do it. And this works for proportions. This works for means, okay? Question number 16 is the same thing. Now, if you want to copy that down, stop the video and get that down. I'm going to delete it and then do number 16 for you since nobody answered this in the forum. Maybe I won't, so that way I can use this video for future years. But what I will do is I'll have you think about this confidence interval is plus p hat plus or minus the margin of error again. So we can do the same thing. We know this is going to be p hat minus the margin of error is my lower bound. And I know that p hat plus my margin of error is my upper bound. And of course, they told us the upper is 0.784. They told us the lower is 0.696. 696. So it's the same way, same deal. Subtract them, divide by 2. That'll tell you the margin of error. Add them, divide by 2. That'll be the center, p hat. I encourage you, if you haven't done it yet, go do the MyOpenMath exercises. I got a few of these kind of questions in there. I'm going to ask you this on the exam, or even the next quiz, maybe. So, all right. Hopefully this helps you out.